Hi guys, just wanted to work through this power rule definition of the derivation of the power rule with the limits. I thought it might be useful because I was trying to figure it out as well. Okay, so let's say we have the question: show that if f of x is x to the n, then f prime of x is same as d dx of x to the n, which is equal to n x to the n. Oops, sorry, this should be n minus 1 to the power of n minus 1. Okay, so first we look at the definition of the power of the derivative, which I've written down here, which is the limit of limit as h approaches 0 to this function. Okay, so next we substitute x plus h into our function, which gives this, and then we replace that function into our limit. So we get this final output here. We're just replacing x with x plus h. Okay. So now what do we do with this whole x plus h to the n situation? Well, x plus h to the n is defined by this summation over here, right? And then we can expand that out as n choose 0, etc., etc. So k goes from 0 all the way to n, which you can see here. So k goes from 0, 1, 2, etc. And you have n over here. So we have n choose k, and then we just substitute k as we come across it into the function. So the first one is n minus 0, because k is 0, h to the 0. So x to the power of n minus 1, because k is 1, and h to the 1. All the way to x to the power of n minus k to h to the k. Okay, so we need some additional definitions of binomial coefficients. So we have here the definition here. And we should additionally know that n choose 0 is 1. N choose n is 1. You can get that by, so you get n choose n for 1 by, say, if you substitute n here, you get n minus n, which is 0. And 0 factorial is defined as 1. So you have 1 here. And you have n factorial again here, and you divide n factorial by n factorial, you get 1. So in fact, n choose n is 1, and then choose 1 is n. Okay. So using these definitions, we replace them as necessary, and then we expand this summation out. So this summation here, we can expand it out to using this, right? So we have here n choose 0, x to the n minus 0 times h to the 0. We just replace that with this n choose 0. We replace that with 1 because we have that here. And x to the power of n minus 0 is just x to the n. And h to the 0, anything to the power of 0 is 1, so we get 1 here. We repeat the same thing here. We have n choose 1 over here, which is just the same as n as we defined here. And we have xn minus 1 right here, and then we have h to the power of 1, right? And we carry on doing this until we all get all the way to the end where we've gotten to n, so k is equal to n, right? X to the power of n minus k, which is again equal to n, and h to the power of k, it's equal to n. So which gives us this equation at the bottom here. So we just, all I've done is just simplify this out. So ones disappear. X to the power of n minus 1 times h to the 1 is just h, etc., etc., all the way out to, and we've up to h to the k because this simplifies out, right? So x to the power of n minus n, which is 0. X to the power of 0 is 1. And here n is equal to k, so just written this as k here. Okay, so it's just simply expanding this, we get this summation. So then we can replace this whole thing back into our limit here. We can replace the whole thing here, which gives us this summation minus, remember we have this x minus x to the n, which we have up here, right? Okay, and the whole thing divided by h. Then we can get rid of this x to the n up here, which with this x to the n, because that cancels out, right? And we have this whole summation divided by h again. And in the next step, I've just distributed this h into each of the summation, each of the parts, right? So x to the n. So we have this part divided by h, we have this part divided by h, this part divided by h, all the way, and then h of the k divided by h. So everything gets divided by 1h, right? So here, you just cancel these out, this goes away, and this goes to 1, and then this becomes 1. This goes to, cancel this out, this becomes 2, etc. So we have here. Now, how we finally end up at this proof is that, as you can see, as we get closer and closer to 0, this becomes a bigger and bigger, sorry, this becomes a smaller and smaller number, right? So if you have 0.1 to the power of 1, so this gets smaller. So we are multiplying this whole term by smaller and smaller values. So if you have 0.1, you have 0.1 squared, you have 0.1 to the power of 3, which is small, power of 4, which is even smaller. As you get smaller and smaller, this basically goes to 0, right? So we can just, this whole thing disappears. This whole part just goes to 0, and h to the k also goes to 0, because as k gets 0 and as k gets smaller, sorry, as k gets bigger and bigger, h is small. It's a really tiny number. So a really tiny number to a really high power is even tinier number. So that goes to 0 as well. And all we're left with is this, which is the derivative of x to the n. All right, that's it. Hope that was clear. Hope that helped. Cheers.